Okay, welcome to the Introduction to Chameleon webinar. As I mentioned just a moment ago, this is a quick reminder that before we get started, if you don't have a Chameleon account, please visit the bit.ly link that's in the chat box to create one now. Today's speaker, Cong Wang, is a senior research scientist in the Network Research and Infrastructure Group of the Renaissance Computing Institute at the University of North Carolina in Chapel Hill. He works on several NSF-funded cloud computing projects, including the ExoGeni and Chameleon Cloud testbeds. He got his PhD degree in computer engineering from the University of Massachusetts in Amherst in 2018. Today's tutorial describes how to use the Chameleon Cloud testbed to perform computer science experimentation. It showcases Chameleon's fully customizable and accessible collection of computation, storage, and networking resources. The tutorial walks through the computer science experimental process and provides hands-on experience with making a hardware reservation and running a pre-designed experiment on Chameleon. It will last about 45 minutes with time for questions at the end. During the presentation, please type general questions in the Q&A box. Members from the Chameleon team are on the webinar and will be answering your questions. Thank you, and welcome, Cong. I believe you're still muted.
Yes, I'm muted. Thank you. Hello, everyone. Thanks for joining the Introduction to Chameleon webinar. So I'm Cong from Runcy. And as a quick reminder, if you don't have a Chameleon account just yet, as Amanda mentioned, please feel free to create one. Otherwise, you can just sit through this tutorial and watch me do it, and you can follow the instructions. We'll send you the link to get some detailed documentation about Chameleon experiments. So let me get started. So first, let me quickly introduce Chameleon to you guys in case anyone know nothing about this testbed. So Chameleon Cloud is a research bare metal cloud testbed. So it provides the programmable resources for the users and is capable of reproducible experiments. This is because all of Chameleon's hardware will be version and will have a unique ID. So in the future, when you come back to this to the same node and boot the same node with your customized operating system or kernel, it's almost guaranteed that you will get the same piece of software and hardware for your experiments. And also, Chameleon provides a variety of hardware that users can choose from. For example, the CPU, like we have Xeon, Atom, or ARM-based CPUs, and we have GPUs, FPGAs, and we also have SDN-enabled network cards on many of the nodes. And also, Chameleon nodes, many of the Chameleon nodes, they have the large capacity of storage. You can run some large-scale data-intensive applications. Also, Chameleon has advanced networking capabilities, which includes the OpenFlow capabilities, and as well as the stitchable VLANs to other testbeds, such as ExoGeni or Amazon Web Services. So Chameleon, in a nutshell, it is a deeply programmable testbed. That means Chameleon can provide you as close as possible to the machine in your lab. All the hardwares at Chameleon are deeply programmable and reconfigurable because you own the bare metal node. That means you own this whole piece of node, and the node is completely isolated from other users. You can power on or off the nodes. You can reboot the nodes from the customized kernels. You can even run the serial console access to the nodes. If you lose the access to the nodes via like a secure shell. And also Chameleon provides the KVM clouds for the ease of use if you prefer VMs. And Chameleon combines the large scale and diversity. That means it's a big data and big compute research testbed for users. It's a large scale testbed. For now, Chameleon has over 600 nodes, and which has over 15,000 cores and over 5 petabytes of storage that distributed over 2 sites, connected via the 100 gigabits per second network link. And Chameleon also provides, as we discussed, provides like diverse hardware like ARM CPUs and Atom FPGA GPUs, and of course OpenFlow switches and many more. Also coming soon, Chameleon is has been constantly upgrading into more storage and more accelerators. Chameleon is also a sustainable production testbed. That means it's cost effective to deploy and operate and enhance the testbed. And you can even own a so-called chi in the box, Chameleon infrastructure in the box, and to own your own Chameleon node at your institute or location. And Chameleon is powered by the OpenStack software. That's a open source software with the bare metal reconfiguration. Chameleon is also open collaborative production testbed for computer science research. So this testbed was firstly started in October of 2014, and the testbed was firstly become available since 2015, and the grant was renewed in 2017. And the next phase, that's the Chameleon Phase 3 grant, has been granted by National Science Foundation, and it will start from 2021. Currently, Chameleon has over 4,000 users, and it has over 500 projects that comes from over 100 institutions. So this diagram shows the Chameleon hardware. That is the, so as you see from here, Chameleon has 2 major sites. Those are 2 big sites. One is the University of Chicago, and the other one is the Texas Advanced Computing Center. So the UC site has a, so the 2 sites are interconnected via the Chameleon core network. That's the 100 gigabits per second public network. And the UC site has 2 racks of Haswell nodes, where each rack has 42 compute nodes and 4 storage nodes. And the tag site has more Haswell nodes, where each the same rack will be the rack will be the same, but it has 10 racks. And also both of the sites, they host the core services, plus the tag site has more central file systems that provides over 4 terabyte of storage, petabyte of storage, and also the tag site has is a heterogeneous cloud that has many other different kinds of nodes. For example, the GPUs, FPGAs, and ARM or Atom, and many other different types of nodes. As an upgrade, Chameleon has added the 2 racks of Skylake nodes to the UC site, and 1 rack of Skylake nodes to the tag site. So both of the sites will have the Corsa switches, which provides the advanced OpenFlow networking capabilities to the users, so you guys can programmably change your network setup with OpenFlow. And it's not showing on the slides. And the Chameleon has also added more recent Cascade Lake nodes to both of the sites. It's not here yet, but you can check those nodes out from the Discover Hardware webpage, which I will show you in this later in this tutorial. So to get started, today the objective is to learn Chameleon basics to run your cool experiments. As some prerequisite, so if you don't have a Chameleon account, please feel free to create one and let us know your username so we can add you to a project, tutorial project. And also, if you want to run the experiment with me, you should have any of the operating system that has a secure shell client, SSH client. So we will guide you through the steps to create a bare metal instance of Chameleon, and you can follow us as an exercise, or you can just listen and use the Chameleon infrastructure getting started guide for your experiments. To find the documentation, I will show you where that is located. So if you go to chameleoncloud.org and go to Learn and Documentation, you will see that this is the pretty comprehensive documentation of everything you can do on Chameleon. And you can go to Get Started. And here it will guide you through the steps that I will discuss in today's tutorial. Okay. So the basic experiment workflow is something like this. So first, we design our experiment, and then we can go to Chameleon's website to discover the resources, available resources on Chameleon. Once you decide what kind of hardware you want to use, you can start provisioning the resources. And then you can configure your nodes and interact with nodes. After we get access to the nodes, we can run a monitoring experiment to show you guys some basic capability of Chameleon nodes, Chameleon testbed. Finally, we can analyze the results. We can discuss the results, and we can share the results with our folks. And last but not least, please make sure to tear down your resources after the experiment is done, because it's a Chameleon Cloud is a shared testbed. So you can, once your experiments are done, you can release the resources so other people can continue to use the testbed. So first step is to discover the resources. So Chameleon has a fine-grained web page to show you to show you a complete list of the available resources on Chameleon. So it's pretty up to date, and it's versioned, so you can make sure that you get the correct resources for reproducible experiments. To do this, if you go to Chameleon Cloud /hardware, so let me show you. So chameleoncloud.org/hardware, you will see a list of resources here. For example, you can choose what kind of nodes you want to have, and with the different configurations, for example, the GPU nodes and storage nodes, and low power Xeon nodes. As an example, I will show you, for example, the most common compute nodes, the Haswell nodes. And you can choose the different size, TAC or UC, and you can choose the different setups, for example, the like 24 threads or 48 threads. And you can also choose some advanced different filters to check things out. And finally, click View. It usually takes a few seconds to load the configurations. So now we can see a complete list of the nodes that are available at Chameleon following your filters. And each of the nodes will have its own ID. So you can reserve the specific node when you are making the reservation. For example, I can click one of the nodes and we can see a lot of details about all kinds of things of this node. So say I have chose my compute node resources, what kind of nodes I want, then I can go ahead and reserve the resources. Chameleon provides two kinds of reservations. One is called the advanced reservation. That means I'm planning for my future experiment. Say I want the reservation to start from next week. You can do the advanced reservation, or you can do the on-demand one. For example, I want to run the experiment right now. That's also okay, depending the availability of the hardware. So all the nodes will be isolated from other users, so you can run your experiments without interfering with other people. So to log into the to your Chameleon portal, you can go to this link. So that's going to be CHI, that's Chameleon infrastructure dot one of the two sites, either TACC, that's TAC, or UC dot chameleoncloud.org. Go to after going there, you will probably see the login the login page showing up. Because I have already logged in, I'm not seeing the login, I think. Yes, so it directly sent me to the to my portal. But if you haven't logged in, then the first step would be to log in. So after you're in it, you will see an overview of this of the project you are in. If you have already joined the project, for example, you can see the like the overall usage, and you can see the different instances you have, and many other things. And also from here, you can choose one of the projects. So for this tutorial, we have a project that's CH820156. So if you want to join this project, please feel free to leave a message on the chat, and one of our community team members will help you to join this project. So after this is done, we can start to create our own LEASE. That's also called the reservations. So if we go to the reservations and the leases, you can see the existing leases here, or the expired leases. And it will also show you the status of the leases. And then we can go ahead and create a new lease. For the new lease, we will need to notice these important fields. One of them is the start and duration of the lease. So you can select start right now or start sometime in the future. And the maximum length of a lease would be 7 days. And you can also renew it once you are close to the expiration date and time of your lease. And also you want to select the minimum number of requested hosts and the maximum number of hosts that you are requesting. So Chameleon will choose a number of nodes for you once you specify the minimum and maximum number of nodes you are requesting. And also the resource properties is where you can choose the type of nodes you want to request. You can request, for example, the different types of nodes. I will show you in a little bit. And finally, don't forget to reserve a floating IP for yourself. because that's the way how you get access to your node, usually via secure shell, that's SSH. So I will go ahead and create a LEASE. Here, for example, I give it a name as my first and last name, and give it a name as a webinar August 25. I will start the LEASE right now, and the LEASE will last for 1 day, and I'm requesting one node, exactly one node, so minimum and maximum will both be 1. And I can choose one of the type of nodes that I want. For example, you can choose like FPGA or GPU nodes or storage nodes. But today, for the simple experiment, I will just run this experiment with a Haswell node. And finally, I create a node that has floating IP on it. So go ahead and click create the reservation. This will sometimes take a little while, maybe a minute or so. Just be patient. And if you want to, you can also refresh the page and see if the request has been sent in. As you see that the status of my new LEASE is creating the LEASE. And you can also refresh the page to see if there's any updates. Now, as we see, there is a starting LEASE. Okay. Now the LEASE is active. So that means your node has been reserved for you. So if you click this LEASE, for some reason, the network is a bit slow today, or the website is not responding. Let's wait for a few seconds. Okay, while we are waiting for it, I'll just go ahead and with other stuff. So once the reservation has been created, you can configure your nodes and interact with the nodes. So the Chameleon will provide the secure access to the nodes, and also you can deploy the bare metal image on the nodes with your selected operating system versions. And also you can assign the public IP to the node, so you can access the node from anywhere in the world. And you can browse the image catalog to see the existing images that you can use for the nodes. And also you can get access to the instance. So to access to the node, you will need a SSH key. So to do this, you can either upload your public key to the system, or you can create a new key pair and download the private key to your computer. So you can, and the the key will automatically be uploaded to your node when you are creating the node and selecting that specific key. Okay. Something bad happened. The gateway timed out. So let me see what I can do. So by the way, if you want to get access to the portal from ChameleonCloud.org, the homepage, you can go to the experiment and choose one of the two sites. Or if you want a VM, you can go to the KVM site. I would go to the tag site. It seems that, okay, this window is faster, so I'm gonna go ahead and use this one. Let me see. Okay, the LEASE is not working well. So to create a key pair, you can go to Compute and Key Pairs. For now, we can see there are two public keys already uploaded to the system. So I will show you how to do a new one. So this one is just a testing key. I can delete this key pair for now. And then I can create a new key pair. For example, I call it the my new key. Let's do this. So new key, August 25. And give it a key type. There are two types of keys that you can use. I usually use the SSH key and create a key pair. Or alternatively, you can upload your own public key to the system. That will also work well. You can click the import public key and just upload your public key there. So now I have my key here. And you can also go to the ChameleonCloud.org/appliances to find a suitable appliance that you want to use. So here, if you go to experiment and appliances, it will come to this list of appliances. So all the icons that has a little Chameleon on it, that means these are the images created by the Chameleon team. And there are some more appliances. For example, this one, it has this kind of icon. That means it's a complex appliance. These appliances usually involve more than one node, and it has some more complex networking configurations. For example, you can create a Hadoop cluster using this Hadoop complex appliance. Today, we will just go ahead with the easy appliance. That's called the CentOS 7. So if you want to use this one, for example, I choose to use this. You can go ahead and click this this one, and you can choose to launch this image on either TAC or UC. For example, I'm going to TAC. It will guide you to this page, and we can start to launch this this image and give it a name. I usually give a name that's similar to my reservation so that I know that this node is associated with my my reservation. So I'll give it the same name for the instance and the reservation and count. Let me make sure the slides are following this. Also, the fields that has a little star on it, that means these are the required fields that you should fill out. For example, here you choose a network. Usually we can just use the shared net. ShareNet means this network is shared by all the community users. So it's also the easiest one that you can use. And I choose a key pair. I created a new key here that I can use. I'll upload this one. Okay. And oops. I think I accidentally clicked the escape button. Let me do this again. Webinar. And now we can go ahead and click launch instance. Now, if we go to the instances page, you will see the new node is being created. And you can see the task that's updating here. So booting up the node will take about 5 to 6 minutes. So now I think it's a good time to answer questions. If anyone have any questions, please go ahead. Feel free to create your own instance if you are interested in following the next steps. So, Zoom is not very friendly to let me see the questions. So if you have questions, please feel free to unmute yourself and answer the question and ask the question.
So we have one question. How do you go about configuring an SDN?
So if you want to run OpenFlow experiments, we do have some networking tutorials that you might want to attend. So those will dig further into the OpenFlow SDN networking topics. And also, alternatively, if you want to know more about the networking things, you can come to the Chameleon Cloud .org and give me 1 second, and go to Learn and Documentation, and go to here, Networking. There are some interesting things you might want to know, and it provides you some knowledge about the basic networking and also VLANs if you want to do stitching and SDN things. Also, I can see a question, assume we put our SSH PAM into, yes, that's correct. We should move that to, move the new key pair to, oops. So the name is new key. move this to SSH, but it can be anywhere as long as you give it a -i option and locate the key, and it should just work. And also, since the key is recently downloaded, we want to change the permission of the key to something like 400 so that it won't complain about permission issues. Any other questions? So since we don't have any questions, I created a same instance yesterday with this name, the CW intro Chameleon. And this one it should be exactly the same as the one I just created to save you guys some wait times. I will go ahead with this one. If you want me to use my own instance, that's fine. Let me know. I can just use and wait for a few minutes for that one. So I will go ahead with this one. So the instance name is CW intro Chameleon. So once the node has been created, we will need to give it a floating IP so that you can get access to that node. So to do this, we can go to network and floating IPs and assign one of the floating IPs to the node that we selected. For example, I want to assign this floating IP to my node. This node is called a CW intro Chameleon and associate. And now we should be able to get access to that instance. So this is the floating IP I have assigned. And I used my own RunC key, but you can use your own key if you need to. To do this, we just need to SSH -i to give it the key location. Usually it's located at the at your home directory .ssh directory. And my key's name is this. The username would be cc Chameleon Cloud at the IP address. Okay. If you see this, something like this, that means you logged into the same IP address before, and that node is gone. So you might want to remove the known hosts. Now I'm in the node. And finally, we can run our experiment. To run our experiment, I will show you how to run your own experiment. And I'll show you how to use the monitoring facilities of Chameleon using OpenStack. So the documentation is here. So if you want to have prefer some text introduction or some like you want to run this by yourself afterwards, you can always go to ChameleonCloud.org and learn documentation. So if you go to monitoring, this will be exactly the same as what I'm gonna talk about. Okay. So you might want to test OpenStack if OpenStack has been installed on your node. because that's needed. To do this, you just type in OpenStack. And if you see OpenStack here, that means it has already been installed. Otherwise, you can use this command to install OpenStack. Once this is done, you want to obtain the OpenStack RC file. To do this, you can go to your portal page and click the top right here and the download OpenStack RC file. Here you will download the RC file to your computer, and you can get the RC file here, open it, and don't forget to add this line to that file to give it some configuration. Otherwise, it will complain about some issues. So we can do export OS auth type equals password. So now we are ready to run. So you can upload this RC file to your node. You can also copy and paste the RC file to the node. Today I will just copy and paste it to my node here. So I'll give it name as rc.sh. I paste the RC here. And this. Once the RC file is in your node, you can go ahead and do source rc.sh and enter your Chameleon password. To test if the password was entered correctly, you can do this. So OpenStack server list. This will list the servers that are running in your project. So you can see the currently I have 4 instances that are running in my project. So today we will show a measurement experiment. To do this, we first need to get the instance ID that we have. So for example, I want to use this one. I want to measure this node. I'll use the instance ID here. This is the ID for this one. We will need Gnocchi to run the experiment. So Gnocchi is the OpenStack measurement framework. So it's a command line for the time series storage of resource measurements. So to do this, we can do Gnocchi resource show this ID. It will show us the available measurement metrics that we can do. Then we can start our measurement. Run this command. Gnocchi measurements. Measures show load at load. We want to show the system load and give it the resource ID. And refresh. So now as we see, it will list the history of the system load. This is pretty much equivalent to the Linux command that's called uptime. And you see, if you repeatedly run the uptime command, you will see the system load as well. So now we generate some synthetic load. we use a little piece of software. It's called the stress. Okay, it has been installed, and then we can synthetically stress the system. For example, I want to stress the 16 CPUs with a timeout of 60 seconds. And now we can see the stress started running, and we can run the Gnocchi command to see the system load change. It will update for every 10 seconds. So let's wait for a few more seconds to show the results here. Now, as we see, the system load is going up from 0.6 to 0.14 to 0.47, and we can let it to finish and see how it goes with the system. Now the stress is finished. It will take a little bit of time for the results to be reflected on the Gnocchi. Okay. Okay. Yeah, I think that's what I want to show you guys, how to measure the nodes. Actually, you can measure pretty much all the nodes in your project as long as you have the correct resource ID and just using the same command. Okay, now we can see that more measurement points are collected into the system. So finally, don't forget to release the resources once your experiment is complete. I'll show you guys how to do this. You can either delete the instance or directly delete your lease. For example, I no longer need my new nodes, so I will just go ahead and delete my lease for the August 25th, as well as my intro to Chameleon nodes. So I'll delete these two leases. Okay, now these two leases are deleted. So if you go back to compute instances, you will see that the nodes are starting to be deleted. Okay, by the way, thank you for deleting this node. So that's all I need to show you for today. And as some Chameleon resources, You can go to the Chameleon user dashboard to see your projects and accounts. That's what I showed you. And you can go to the documentation to find the bare metal user guide, or you go to the FNQ. Oh, it's not here anymore, but let me show you how to get there. So if you go to documentation, and all the things will be listed in this page. And also you can communicate with the Chameleon team. So you can go to you can send email to this mailing list. So it's help@chameleoncloud.org. So it's almost guaranteed that someone will come back to you if you have any questions. And also you can join the Chameleon user mailing list. So that's Chameleon users at chameleoncloud.org. And you can follow us on the social media. If you go to chameleoncloud.org, you will find a lot of information out there. So that's all what I have for today. And feel free to ask questions if you have any. Otherwise, thank you for attending.
Okay, and we will be able to have this available on YouTube. So this should be available on YouTube early next week, just so everyone is aware. But thank you so much, Cong, for presenting this webinar. We appreciate your time and that of our attendees as well. To learn more about Chameleon, please visit our website at www.chameleoncloud.org. Thank you all and have a wonderful rest of the day.
Thank you. Bye.